discrete hypothesis testing, example number 3. We have a drawing pin, and the probability of it landing point up is 0.35. Someone who has a very exciting life does 400 trials of seeing which way it lands up, and it lands point up 153 times. What they want to do is to test at the 5% level whether the probability of point up is actually greater than 0.35. They're told it's 0.35. That's going to be the null hypothesis bit up there. So, to start with, what distribution will this follow? If x is the number of ups, okay, x follows the binomial distribution 400, 0.35 under the null hypothesis. So our null hypothesis is that p equals 0.35. Our alternative hypothesis, well, we were told it's more than that, so p is greater than 0.35. Can anybody remind us, because we haven't looked at this for about 2 weeks, what do we do now in words? What do we do in this situation to do this test?
Change the mode?
No? Well, we might do, but that's not the idea of the actual test. We try and find the probability of getting what we observed or more extreme than that. Okay? So the key thing that what we've got to do now is for our test is we are going to find the probability of 153 or more point ups. And if that probability is less than 5%, what will we do? If the probability of getting what we saw, or more extreme than that, is less than 5%, what will we do in relation to our hypothesis? We will reject H naught. Reject H naught, and we will accept H1. Okay, right, there we go. So, we will use a normal approximation, Dan, because this is so big up here. So we will say that x will follow the normal distribution, which will be n, p, 1 minus p, which turns out to be something on my next page, 140, 91. I know we're going fairly fast, but are we okay with this so far? Okay. So what we need, if we're working with binomial probabilities, is we want the probability that x is greater than or more than equal to what we observed, 153. Why have I specifically put this binomial thing down here? Because I need to do a continuity correction, yeah. Because I'm moving from a discrete distribution to a continuous distribution, doesn't matter whether I put my extra bar on here or not, makes no difference. But what value is going to go here? Yes, 152.5, good, because I've got to include the 153. That's a greater than probability. What do I do first of all then? Don't like greater than. 1 minus the less than. Okay, and this is now like what I call a normal question. It's a straightforward normal probability question. 1 minus phi of x minus mu over sigma. To speed it up, I will tell you that that comes out to be 1 minus phi of 1.310. I will tell you that that number there, when you phi it, is 0.9049, and when you take it away, is 0.00951. So in other words, that's 9.5%. So the probability of getting what we observed or more extreme is 9.5%. So what?
We're accepting each one.
Yeah, there's no evidence that this is such a rare occurrence that we should move away from H0. So as the 9.5 is not smaller than the 5%, it's not a rare event, we will accept H0. i.e. that P really does equal a 0.35. And there's just one little bit to go on the end. What I've got down here, what rate of observed incidents, hang on, no, I think we'll scrap that bit. Oh, there's another example. There's another example.
You just do like just an inverse binomial cumulative distribution, and then you find like the value of that would. How do I explain it?
And you'd compare that with the 5% thing in the tables. I think I know what you mean, and yes, you're right.
You can so you can find just by doing inverse binomial that 156 is what you would require. Is the number of is the number that you would require for that for that probability for it to be in the critical region as such.
That is exactly the right approach, and actually that's going to come out in example 4, which, to be honest, we can't do before the bell. It's that much. Can we just do it now? No one's really moaning or getting up and complaining, so let's just do it now, then we can finish the chapter. If you need to go, just walk out and then watch the video. There'll be a link on the KLP page. You guys go. Okay, right, this one is about accidents. Actually, I'm going to do this one in a different video. I'm going to run out of time otherwise.